In this session, we'll see how ACLs work at the binary level, IP access control list, MAC access control list, port access control list, VLAN access control list, and the difference between the preferred port mode and the merge port mode. First of all, what is an ACL or access control list? In the general sense for Cisco, it is just a series of logical bitwise operations looking for a particular match. We are going to execute these logical bitwise operations in a sequential manner from top to bottom. So we are going to feed some data into our ACL and we are going to evaluate the first logical bit operation looking for a match. If we don't find one, we are going to do the same with this next one and then with the next one until we run out of logical bitwise operations. And at the end of the ACL, we are going to find a deny all action that exists there by default implicitly. However, if at some point we find a match, we are going to stop processing the ACL there and we are going to apply a deny or permit action to this data. The meaning of this permit or deny action will depend on what are we using the ACL for. Let's illustrate this with an example. Let's feed this 8-bit wide data to our ACL. Notice that this is just an example because in real life, we are going to work with 32-bit or 128-bit IP addresses or 48-bit MAC addresses. The first entry has this wildcard that is going to help us execute a bitwise operation on the source data. Remember that the bits that are set to 0 are going to be called the match bits, and the bits that are set to 1 are going to be called the don't care bits. These are usually represented by an X. And we are also establishing what is the expected address that is going to be used in order to validate whether this entry is successful or not. In the second entry, we also have a wildcard. This may be different than the first one, and we have another expected address that is going to help us to validate whether this entry was successful or not. So the process is the following. We are going to feed our data to the first entry, where we are going to execute a reverse AND operation at the bit level using the first wildcard. This will be the result. We are going to compare this result with the expected match value. In this case, we don't have a match, so we are going to jump into the next entry where we are going to execute the same. We are going to feed our source data to our second wildcard. We are going to execute a reverse AND operation. This will be the result. We are going to compare this result to the expected address. In this case, we have a match, so we are going to stop processing the ACL there, and we are going to apply a permit or deny action to our data. We can assign sequence numbers to our entries. Lower sequence numbers get processed first. Back in the day with old iOSs, we didn't have sequence numbers, so if we wanted to change or edit or modify an ACL, we actually had to delete it altogether and build it from scratch. Nowadays, we don't have to do that. We only have to modify a specific entry with a specific sequence number. The actual name for an entry within Cisco is Access Control List Entry, or ACE. There is actually a maximum limit of how many ACEs we can have within an ACL. This will depend on the operating system that we are working on. However, there are commands that will allow us to change this limit. In real-life networks, ACLs are seldom executed in software. Most of the time, they are executed in hardware. They are loaded into the TCAM, so they can be executed in a single clock cycle. And the next question will be, why do we need ACLs? The answer for Cisco will be, we use ACLs for several features. We have tried to summarize most of the features where ACLs are used here, where we are showing the feature name, what is the meaning of the permit or deny action within the ACL for this feature, and what is the command in order to use this feature. So we can use ACLs for packet filtering, to secure bitwise, to allow permissions to access SNMP, netconf, HTTP, or RESTconf resources. We can use ACLs to create quality of service class maps, COP class maps, route maps, and we can also use ACLs for prefix filtering, although IP prefix lists are recommended for this matter. Now, in this session, we are going to focus on packet filtering. So we are going to be feeding packets to our ACLs. And when we apply a permit action, we are meaning to forward this packet. And when we apply a deny action, we are meaning to drop this packet. Okay, let's talk first about IP access control list. We have two types, standard and extended. With the standard, we can provide only source IP address information, and the protocol will be implicitly IP. For extended, we can supply source and destination IP address information. We can pick the protocol, not only IP. We can work with ICMP, GRE, TCP, UDP, and so on. We can provide protocol options, for instance, the ICMP message type or the TCP port number, and we can also provide a time range. We're going to talk about time range later on. Let's talk about the commands that we have available in order to create IP ACLs. We have the command access list and we have the command IP access list. Let's talk first about this command access list. These were really flexible back in the day. With old iOSs, we were able to create several types of ACLs. However, that is not the case nowadays. We can only create IP ACLs and MPLS ACLs with the current iOSs. This command will allow us to create a standard and extended access control list. However, only numbered ones. That will be a disadvantage. These are the ranges for the standard and extended access control list. With old iOSs, this command will not allow us to establish a sequence number to our entries. However, with more recent iOSs and with iOS XE, we are able to add a sequence number to our entries. So that is a good thing nowadays. And this command has the disadvantage that for every single entry, we need to repeat the command access list and the access list number. That does not happen with the other option that we have available. So let's talk about the other option, which is the command IP access list. With the command IP access list, we can create a standard and extended access lists, not only numbered, but also named access list. That is a great advantage. We can also enter into what we can call the access control list mode, where we can work with a sequence number and our entry, so we don't have to repeat the whole command every single time. And the other advantage is that this command has always made available the possibility to add a sequence number to our entries. As a final note, let's remember that we can use the host key in order to avoid typing this, and we can also use the any key in order to avoid typing all of these. We can configure a time range to each of our entries with an extended access control list. This means that these particular entries will get into action when the time of the device matches this time range. Before configuring a time range to an entry, we need to previously create the time range with the command time range and the name. These are the ways to create time ranges. Now let's move on and talk about the MAC access control list. In this case, these access control lists work pretty much as IP ACLs, but we are going to process MAC addresses at the binary level. Back in the day, we were able to create a standard and extended numbered MAC access control list with the command access list. This is no longer the case. With iOS XE, we can only create extended named MAC access control list with the command MAC access list extended and the name of the ACL. Now, when creating our entries, we cannot provide a sequence number. That is not really a good thing. However, we can supply a source MAC address information, destination MAC address information, and optionally a protocol number or name. Now, as a final note, remember that we can always use this host keyword in order to avoid typing all of these. We can use the any keyword in order to avoid typing all of these. And if we wanted to reference the broadcast address, we can use this code or this code. Remember that as this session is focusing on packet filtering for ACLs, if this entry is successful and we configure this entry for a permit action, we are going to be forwarding this frame. And on the other hand, if we configure this entry for a deny action and this entry is successful, we are going to drop this frame. Now let's move on and talk about port access control lists. A port access control list is nothing new. It is not a different technology than what we have seen so far. The thing is this: if we apply an IP access control list to a layer port, it is going to become a port access control list. In the same manner, if we apply a MAC access control list to a layer 2 port, it is going to also become a port access control list. So in summary, port access control lists are nothing different. They are just an IP ACL or a MAC ACL applied to a layer 2 port. Now, port ACLs are loaded into the TCAM, so most traffic is going to be TCAM switched, that is in hardware. However, there are some exceptions. For instance, NAT traffic or packets with options are going to be software switched. Now, in order to configure these ACLs into ports, let's remember that port ACLs can only work in the inbound direction. So this will be the command in order to configure an IP ACL to a layer 2 port in order to become a port ACL. And this will be the command in order to configure a MAC ACL into a port, a layer 2 port, in order to become a port ACL. Notice that we can configure up to only one IP ACL and up to only one MAC ACL per layer 2 port. Now, these layer 2 ports may operate in one of two existing processing modes. They can operate either in preferred port mode or in merge mode. This will be the command in order to enable preferred port mode, and this will be the command in order to enable merge mode. The default mode is merge mode. We are going to talk about these modes later on. Okay, let's move on and talk about VLAN access control lists. Although they are called access control lists, these are not configured in the same manner as we did with IP access control list or MAC access control list. Probably the name is not really adequate for this feature. Maybe they should be called VLAN traffic maps or something like that. However, I digress. The objective of VLAN access control list is having control over the traffic that is entering the VLAN, so we can decide whether to forward this traffic or drop it at it is trying to enter the VLAN. And we also have control over the traffic that wants to exit the VLAN, so we have control over to whether forward it or drop it as it wants to exit the VLAN. So notice that this feature works in both directions, in the inbound and outbound direction. We don't get to decide what direction we want to use it for. It is going to work in both directions by default. So if we wanted to configure a VLAN access control list, we will use the command VLAN access map, the name of the VLAN access control list, and the sequence number for this entry. We may have several entries for a VLAN access control list. We are going to identify each entry with a sequence number. Lower sequence numbers are executed or processed first. Now, within each entry, we will have access to two commands, match commands and one action command. So we may have several match commands where we are going to reference IP ACLs and MAC ACLs, and we may enter one action command that will be either drop or forward. Now, after configuring our Vacl, we are going to assign it to one or many VLANs with the command VLAN filter. VLAN filter, the Vacl name, and the VLAN list. In order to validate this feature, we can use the command show VLAN filter in order to see to what VLANs have we assigned what Vacls, and the show VLAN access map to see how our Vacls are configured. Now let's summarize where are we going to place our ACLs within a layer 3 switch. Our port ACLs are going to be placed at layer 2 ports. Remember that these only support inbound direction. Our VLAN access control lists are going to be placed within VLANs. Remember that these access control lists support both directions. And our IP access control lists are going to be placed at SVIs. Remember that these access control lists support both directions. Now the following question will arise. In what order are we going to analyze or process these access control lists as traffic travels through our switch? And the answer is It depends on how the traffic is moving. Is it moving through the same VLAN or is it moving through different VLANs? And more importantly, how did we configure the entry point layer 2 port? Did we configure it to use merge mode or did we configure it to use port prefer mode? We are going to analyze these cases now. First of all, we are going to analyze the cases where the entry point was configured to use merge mode. Remember that this is the default mode. So the first case will be for traffic that is traveling through the same VLAN. In this case, we are going to process the access control list in the following manner. First, we are going to analyze the port access control list for this port in the inbound direction. That is the only direction that port access control list support. Then we are going to process the VLAN access control list for the blue VLAN in the inbound direction. And then we are going to process the VLAN access control list for this same VLAN in the outbound direction. Now we are going to analyze the case where traffic enters through one VLAN and exits through a different VLAN. Notice that in this case, the traffic has to go through SBIs. Remember that we are still analyzing merge mode. In this case, we are going to first analyze this port access control list in the inbound direction. Then we are going to analyze this VLAN access control list for the blue VLAN in the inbound direction. Then we are going to analyze the access control list number 1 for this SBI in the inbound direction. Then we are going to analyze this access control list number 2 in the outbound direction. And finally, we are going to analyze the VLAN access control list 2 for the green VLAN in the outbound direction. Now let's do the same exercise when the entry point or port is configured to use the prefer port mode. Let's analyze first the case where traffic travels through the same VLAN. So it enters through this port and exits through this port where both ports belong to the blue VLAN. In this case, in prefer port mode, we are going to analyze first the port access control list for this entry point in the inbound direction. And then for the outbound direction, we are going to process the VLAN access control list that is configured for this blue VLAN. And that's it. Now we are going to analyze how ACLs are processed when traffic enters through a VLAN and exits through a different VLAN. Notice that in this case, traffic has to go through SBIs and that this port is configured for prefer port mode. So in this case, we are going to process the port access control list for this port in the inbound direction. And for the outbound direction, we are going to process this ACL number 2 in the outbound direction and the VLAN access control list 2 that exists for the green VLAN in the outbound direction. And that's it. Just a final note here, regardless of how we configure the entry point to operate, the processing for the outbound ACLs is always the same. As a summary of what we saw in this session, remember that IP ACLs can be applied to layer 3 interfaces, for instance SBIs, and these are usually bidirectional. But we can also apply IP ACLs and Mac ACLs to layer 2 interfaces. In this case, they are known as port ACLs, and these operate only in the inbound direction only. And we can configure VLAN ACLs and we can apply them to VLANs. In this case, remember that these will operate in both directions.